All right, welcome back. Section 5.2, we get into rational numbers. If you remember back to 5.1, we looked at turning fractions into decimals. And today we'll work with changing forms of the fractions from mixed to improper and improper to mixed. And we'll also look at taking a decimal and turning it into a fraction. All right, so our learning targets for today are to write rational numbers as fractions, and then identify and classify rational numbers and what sets they belong to. Okay, so remember that rational number is any number that can be written as a fraction. And it's easy to recognize, right? If I see 1/2, right, I can see that that's a fraction, that's a rational number. Might not be as easy to see that 3 is also rational because I can write that as 3/1. But what if I have 5.27? How do I know that that's a rational number? The term terminating means to end. So since this ends and it doesn't keep going on, that's a rational number. So 0.125 is a rational number. Now, we should recognize 0.3, right? And we talked about bar notation, right? I could have just written that as 0.3 with a bar, and that implies that the 3 keeps repeating. That's a repeating decimal. It's a patterned decimal. That is also rational, right? So if it repeats, so if I have on my calculator 0.123, 123, 12, right? And it'll eventually run out of space. And we could see that written as 0.123. That's my period, right? And then that repeats. So I put the bar over all 3. Those are rational numbers, right? A non-rational would be if you had something like 0.57321 right? Keeps going on. There's no repeating cycle or repeating period. That is not rational. So let's look at the different number sets and then we'll talk about how to classify, right? So we start with natural numbers as the most basic, right? And those are just counting numbers. When you start to count, it's 1, 2, 3, 4, 5, 6, and so on, right? Just going up in the positive direction. So we have this number set that we'll call natural numbers. All right, and that consists of all of these that we just talked about. Now, whole numbers, okay, includes all of those natural numbers, plus you add 0 in there. Okay, so we have the counting numbers, plus we add 0. That's considered a whole number. And then we add integers, right, which where we keep those same 0, 1, 2, and so on, but we add the negative aspect, right? So integers include negative numbers, right? So that's the addition there. And then we include, run out of room there, right? Rational numbers, right? And the letter used for that is Q. And that's where we add fractions and terminating decimals, right? And repeating decimals in there. So something that starts here as a natural number is also considered a whole number, is also considered an integer. It's also considered rational. Okay. Whereas if I say, okay, let's label the number 0. Okay. Well, it's not a natural number. A natural number starts at 1, 2, and goes on that. It starts as a whole number, which also means it's an integer, which also means it's rational, right? So if I were going to list the sets of 0, I would say it's a whole number, it's an integer, and it's rational. Let's say that I have the number -7. Okay, well, where is the negative introduced? It's introduced at integers. So that would be an integer, and it would also be a rational number, right? Well, let's say we have 1/2. Okay, 1/2. Well, it's not natural, right? Don't count there. It's not a whole. It's not an integer. It's introduced at rational. So I can only consider 1/2 as a rational. It's not an integer. It's not a whole number. It's not a natural number. All right, so let's look at some more examples. Okay, identify what each number belongs to, right? And here's our key. We'll use N to say natural, W for whole, I for integer, Q for rational. And then if it's not rational, we'll just say not rational, which means it's not a part of any of those sets. So 13, is that a natural counting number? Yes. So that's natural. And then I can just list the rest, right? If it starts as natural, it's all the way up to here. If it's not any of these four, we say it's not rational. Negative, right? Where does the negative get introduced, right? That gets introduced as integers, right? That's where the negatives come into play, which means it's also a rational. Negative 7.5, okay, it's negative, which was introduced to integers, but it's not a whole number, right? So this would just simply be rational. And I know that because it's a terminating or an ending decimal. 2 3/4, right? So this is just for terminology, right? This is a mixed number. It has a whole and a part. You could change it to a decimal to see that it ends, or I should know that it's written as a fraction. That is a rational number. 0.713, right? Terminating decimal. I know that that is rational. Here we have 0.45312 dot, dot, dot. This right here means that it keeps going. And I can see there's no pattern. There's no repeating cycle there. So I would just say that is not rational. All right, so that's how we list what sets does it fall in. All right. Looking at mixed numbers and integers as fractions, okay? So first off, a mixed number, right, is a whole number with a part that goes with it, right? So number 2 and 3 are mixed numbers. And then an integer, we said, is just a whole number that's either positive or negative, right? And so to change an integer into a fraction is really simple, right? I just say it's 21 and I put it over 1, right? Numerator is negative 21, denominator is 1. And if I were to divide that out, right, which we looked at in section 5.1, I can change it to the decimal or equivalent by just dividing these two values, and I end up back at negative 21. Now, with the mixed number, where I have my whole and my fraction, I start with, I take the denominator and I multiply this whole number, right? 7 times 3 is 21, right? And I should know that 21, let me clean that up a little bit. 21 over 7, right, equals 3. So that's this part. Plus, I have this 6 over 7, right? So I'm going to add this right here, right? 21 and 6 is 27 over 7. So these two are equal. It's 3 and 6/7 and 27 over 7 are the same value, right? Just two different forms. This is a mixed, this is an improper fraction. All right, so here if I take the denominator, 8 times negative 4, I get negative 32, right? Negative 32 over 8, plus I have this fractional part, which is 3 over 8. Notice it's really easy to do that because I have the same denominator, but I have to be careful, right? I have to be careful because I say negative 32 plus 3, right? If I were using my integer, so I'm just going to hold on to that because I know my whole value is negative, right? And I'm going to add 32 and 3, which gives me 35 over 8, and my number is negative. All right, so there's 35, negative 35 over the 8 is the same as negative 4 and 3/8 left over. And then 52, right, in integer, I can just put that over, I can just put that over 1, right? So 52 over 1 and 52 are equal to one another. This is written as an integer. This is written as a fraction. Now let's go take an improper fraction, right, where the top is bigger than the bottom, and write it as a mixed number, right, which would be a whole and then whatever's left over. So I start, right, by saying, okay, how many times does 7 go into 72? Okay, well, I know 7 times 10 is 70, right? So it goes in there 7 times, right? But I know that 7 times 10 is only 70. So I have 2 out of 7 left over. So here, I know that 9 goes into 14 once, right? And that's equal to 9. Okay, so 14 minus 9 would give me 5. So I have 5 out of 9 left over. Right, and you can look at it as long division too, right? We did that, so I got 29, divide that by 2. 2 goes into 2 once, right? It's equal to 2, so that cancels, drop the 9. 2 goes into 9 14 times, that's equal to 8. So I have 1 left over, right? And that's 1 out of 2. So this would be same as 14, remainder of 1 out of 2. Right? And you can see that 2 goes into 29 14 times, right? 2 times 14 is 28, which is 1 remainder there. 33 divided by 3, I should know that that's 11, right? Or I could write that as 11 over 1 if I wanted it in fraction form. Okay, either way is fine. All right. Getting into decimals as fractions. Okay, so first want to get into the terminology. Right, if you have one decimal place, that's tenths. The next decimal would be hundredths, and then you get thousandths, THS. All right, and so on. So to turn it into a fraction, anything that terminates, right, I can read that that's 1/10, right? 1/10. And since it's only one digit, that means I only need 1 0 on the bottom. So here, the next one, 35 goes on top, and this would be hundredths, right? Or there's 2 values, so I'm going to have 2 zeros. Now, I want to write it in simplified form. So what I have to do is I have to reduce it, right? And I know that 35 is divisible by 5, and so is 100. So 35 divided by 5 is 7. 100 divided by 5 is 20. Now, these two do not have any common factors other than 1, so that is my simplified form. Now, you can always check your answer out because I can say 7 divided by 20 in my calculator, and it should equal, right, 0.35 if you've done it correctly. All right, so number 3. Notice we have 3, right? Tenths, hundredths, thousandths, right? And I can just take the 162, and there's 3 digits, so I'm going to have 3 zeros. And then I have to reduce that. So I got to find a value that goes into both 162 and 1,000. And you can start small and just check, right? I know that 2 goes in here, right? So if I divide that by 2, I get 81. And I can divide 1,000 by 2 and get 500. Right? Now, 81 and 500 do not have any common factors. Right? So there's my solution. And then I can check just to make sure I reduced it correctly. I can do 81 divided by 500 in a calculator, and it should equal 0.162. All right, see if you can do number 4 and 5, and then we'll talk about number 6 as well. So pause the video here and do number 4 and 5. All right, so looking at number 4, right, 97 out of 100. And remember, when it's in hundredths, right, that's giving you a percentage, right? So if I look back at number 2, that's out of 100, right? That's 35%. Okay. So if you got 35 out of 100, that'd be 35%. If you got 7 out of 20, that'd be 35%. Number 4 here is a 97%, right? 97 out of 100. In number 5, it was 68, negative 68%, right? Negative 68 over 100. That could be simplified, right? 97 and 100 had no common factors other than 1, so that can't be reduced, but this can be, right? I can reduce that down to negative 17 over 25. Now with number 6, okay, I know that 5 is the whole, and then the 1500ths is the part, right? And so I can keep that as 5, and I can reduce this. I know 5 goes in there, right? So I'm going to divide by 5, divide by 5. So 15 divided by 5 is 3. 100 divided by 5 is 20. So that's 5 and 3/20ths. Or if I wanted to go as a fraction, right, an improper fraction, I can say that 5 times 20 is 100 plus 3 would be 103 over 20, right? And so those either form would be okay, unless it's multiple choice. Obviously, then you have to pick the form that it's in, or if it specifically says how to leave your answer. Either way, if it doesn't say, is fine. So your practice for today, page 208, doing numbers 12 through 21, 34 through 40, and then 54 to 57. All right. Hope you have a great day. We'll talk to you soon.